So this is part 2 of our video series of numbers and operations. So we'll begin with decimals and our decimal operations. And so a decimal is a number to the right of the decimal point. So when we say 148 and we see the decimal to the right, well, 148 is the whole number. And the decimal would be 768 thousandths. So we're going to read this by specific place values. So that's what our chart looks like here. Each value in the decimal is 1/10 of the value to its left. So if we have the number 234, and then how do we read this correctly? Well, the 0, we'll start at, we'll work from left to right. So 2 is the hundreds, 3 are your tens, 4 is your ones place. Now 0 is your tenths, 6, not hundreds, but hundredths, 2 thousandths, and 7 is in the 10,000ths place. So we would read this as 627 10,000ths. So you just notice that you started at 200, and then we went to divided by 10, and then we're at the tens, and then we're at the ones, and then we're at the 1/10ths, and then we're at the 100ths, and then the 1,000ths, and the 1/10,000ths. So that would be our denominators. You're dealing with the hundreds, tens, ones, and then you see the fractional place value from there. So what we typically say in our everyday living, especially when we're talking about temperatures, we would say 98.6, or we would say, we would say in gymnastics somebody landed a 9, or sometimes we even say they landed a 9.8 or 9.8. So we typically use that point as part of our decimal day to day, but really mathematically we would want to read that as 98 and then the correct place value of 6/10. All right, let's look at rounding. Still working with decimals. So when we think about rounding to certain place values, when we take 19 and 2600ths, and I want to round it to the 10th. So I'm thinking right here that's your 2/10. So that's the place value. So one way to do this is looking at a low and a high, and here you have 19 and 2/10 and 19 and 3/10. That makes sense of what it's going to be between, because we asked to round it to the tenths place. Is it going to be closer to 2/10, or is it going to be closer to 3/10? Well, halfway is going to be 19 and 2500ths. So where does this 19 and 2600ths lie? It's somewhere right there. So we would see that it's closer to 19 and 3/10 than it is to 19 and 2/10. Again, let's look at rounding. I have 225 and 735 thousandths, and I'd like for you to round it to the hundredths place. So we're going to identify the hundredths right here, and then we can look, a rule there is that we could look to the right and determine if that's going to be placing it to the next hundredths. So I have 225 And is it going to be closer to 7300s or 225 and 7400s? Well, this value right here to the right is going to tell you that you're going to round it up. So those are some of your rules. If the digit is 5 or greater, when you're looking to the immediate right of that digit, then you know you're going to round it up to the next place value. If the digit is less than 5, then we'll round it down. So now let's look at adding decimals. It's always a good thing to think about estimating. We can ask students to estimate. So we've got 5 and 7. And if I estimate it to the nearest whole number, so that would be 15 and 5. So that would be approximately 20. If we're thinking about estimating that. And then next, if we're asked to, if I want to use estimation, I kind of did this front end estimation where I just looked at the first digits. I looked at 5, 7, and 8, and then added those up. Now, if I want to know what the exact sum would be, then I need to make sure that I line up my decimal points in the correct place value. And if I need to, I can fill a place value with a 0. Now with that allows me to look at the different place values to add. So I'll add the thousandths, which would be 3 thousandths, 5 hundredths. This is 3 tenths and 1 tenth, so that'd be 4 tenths. And then we have our 20. So 20 and 453 thousandths, which is real close to our estimate, which was 20. We look at the part B, 2 and 25 hundredths. I'll round to 2, and then 3, and then 12 if I'm going with the front end estimation. So that would put me approximately at 17 on the low end. And if I rounded everything up, that would put me at approximately 20 on the high end. Now if I go ahead and add those together, so it's 2 and 25 hundredths, 3 and 75 hundredths, and 12 and 5 hundredths. So again, line up your place value. So this is going to be 15 hundredths, and 15 hundredths is 5 hundredths and 1 tenth. So now that's 9. That's going to be 10 tenths or 1. And so that's why I regrouped the 1 over here. So that's going to be 5, 6, 7, 8 wholes. So that'd be 18 and 5 hundredths, which I knew was somewhere in between 17 and 20 for my estimate. So if I look at subtraction, I've got 11 and 13 hundredths, take away 3 and 45 thousandths. So I know that that's going to be about 8, somewhere around 8. So with the subtraction, I'm going to rewrite just the space a little bit with my So you're thinking about regrouping your number. And so instead of 3 tenths, I'm going to have 2 tenths. I'm going to regroup this hundredths to 10 hundredths minus 5 hundredths would be 5. Can't take 4 tenths from 2 tenths without going into the negative. So I'm going to regroup here, and that'll give me 12 tenths, take away 12 hundredths, take away 4 hundredths would be 8 hundredths. And then I can have my 0 0 minus 0, and then 11 minus 3. So I get 8 and 85 thousandths is my answer. So looking here, that would be about, so 22 take away 12, so approximately 10 as an answer. And I'm subtracting, so I want to line up my place values. And 8 hundredths take away 5 hundredths is 3 hundredths. I can't take 8 tenths from 7 tenths without going into the negative, so I'm going to regroup 17 tenths here, which I brought 10 tenths over plus the 7 tenths, so 17 tenths take away 8 tenths would be 9 tenths. And then I'm going to regroup, and that would give me 11 ones take away 2 ones, so I'm at 9 and 93 hundredths as my answer, which was real close to my estimate of 10. Now let's look at multiplying. There are several ways to look at multiplying decimals. I would encourage students to go ahead and multiply it as normal, and then think about, well, it's not 82, it's actually 8 and 2 tenths. So that means this is 10 times smaller. And it's not 25, it's 2 and 5 tenths, which is another 10 times smaller, which means we had to divide, we're going to divide this result by 100. So we go ahead and we can do our algorithm here. 41, and place value, so 2 times 2, 4, that would be 16 hundredths. So I'm going to get, so it's not 2050 as an answer, because remember, I've got to divide by 10 twice. So my decimal point's here, so I'm going to divide by 10 once, divide by 10 twice, and so I'm going to get 20 and 5 tenths for 20 and 50 hundredths. Those are the same answers. And then if I have 12 and 5 hundredths multiplied by 5 and 3 tenths, if I wanted to estimate that, that would be about 12 times 5, so I know approximately 60 as an answer. So I would suggest that students multiply this as it was a normal multiplying, but remember that it's not 1,205, but 12 and 5 hundredths. So that means this number needed to be divided by 100 or divided by 10 twice, and 53 needed to be divided by 10. So ultimately we are dividing by 1,000, which is 3 place values that will move our decimal point. So we're going through our standard algorithm. So it's not 63,865. Remember, I need to divide it by 10 3 times, which is the same as dividing by 1,000. So we would get 63 and 865 thousandths. All right, we'll look at division. And division is going to be the same way. We've got 10 and 1 hundredth divided by 4 and 55 hundredths. And so remember, there's different ways to, like I said, divide this. I would encourage my students to look at what the place value means in this case. And this is actually 1,001. And the place value of this 1 here is hundredths. And this is actually 455 hundredths, because that's what's your place value of this 5 here. So with that method, that allows you to look at, well, if you divide 100 divided by 100, that goes to 1. And so now you're left with 1001 divided by 455. And notice that my divisor is a whole number. And that is what you want your students to do with dividing, when they're dividing decimals. And that is to make sure that, to get started, that the divisor is a whole number. So if I move the decimal to the right 2, well, that would be the same as multiplying by 100. Well, this would need to multiply by 100 too, and notice where you end up with the decimal. So you actually end up with 1001 divided by 455, which is exactly what you get down here. And so that 455, that would, so, and also I'll place my decimal point in case I need to go into tenths. Well, that would be 455 multiplied by 2, so that would be 910. And when I subtract that, I'm going to get 91. And bring down my decimal here. And so multiply this by 2, and I should get 2 tenths times 455 should be 91. I get a remainder of 0. So that just means my quotient was 2 and 2 tenths. So that just means that if you took 4 and 55 hundredths and multiplied it by 2 and 2 tenths, you would get 10 and 1 hundredth. Same here, we would say 2,925 hundredths, because the 5's in the hundred spot, the 8's in the tenths. So we would say 78 tenths. Now, if I leave it like this, notice that this is 100 divided by 10, and that's going to be 10, which means whatever I get as a result here, I'm going to have to divide by 10. Or I could take another way to write that. So if we start out at 29 and 25 hundredths divided by 7 and 8 tenths, I move the decimal point 1 to the right, 1 to the right. So that's going to give me 78 divided by 292 and 5 tenths. Either way, I'm going to have to divide my answer in the end. So if I take this approach here and take 2,925 and divide by 78, well, that should be I'm going to get 30 something. Just go through my subtraction here. And that should be 7 times 78. So that should be, what, 546. So 390 as a result. And then that would multiply by, so 5 multiplied that should give me 390 as a remainder of 0. Okay. So notice that my result is 37.5, but I need to divide it by 10, because I still had that 100 divided by 10, which is 10. So now that's going to give me 3 75 hundredths. Well, if I go with this approach and make the divisor a whole number and move the decimal point, so now I'm at 78 divide 292. I would get the same answer, but I wanted to show a different way of that. So let's look at, if I take the 2,925 hundredths and divide it by 78 tenths, if I wanted a common denominator of 100, then I would need to multiply by 10 divided by 10, which would be 2,925 hundredths divided by 780 hundredths. So when I take 780 and divide it by 2,925, I would actually get 3 and 75 hundredths when I complete the math. So I'm going to get the same answer, just two different methods. The goal being with dividing decimals is that you want your dividend to be, your divisor to be a whole number. So next, let's look at comparing fractions and decimals. And when you're comparing, so a fraction, when we think of that, we can convert that to a decimal. And to do that is a division. And so what we'll do is we'll take our denominator, 8, and we want to divide it by 3. And we know that 8 will not divide 3 a whole amount of times. So we look at extending our place value. So 8 would not divide 3 a whole amount of times, but it would divide 3 tenths, and that would give us 2 and 4 tenths. And when we subtract, we get 6 tenths. Bring down our 0. 8 would divide 60 hundredths, 7 hundredths times, so that would be 50. That's 56 hundredths. Subtract, and we're going to get 40 thousandths. And then 8 would divide 40 thousandths 5 thousandths times. So our result is 0. So 3/8 is the same as 375 thousandths. We just converted the fraction into a decimal by dividing the denominator. How many times will that denominator divide the numerator? So if we have to, we can always change fractions to decimals if we need to do some comparisons. And so if we look here, and I want to know from greatest to least, notice that we do have some negative numbers in here. So it's a quick little lesson on, well, if this is 0, this is 1 and 2 and 3. This would be 1.5. This would be 2.5. So notice how moving this way from left to right, as the numbers get larger, the number to the left is smaller. Well, it's the same idea, but when we look this way, we're going to have 1, 2, 3. We'd actually have half here. So we'd have -1/2, or -1/2, -1, -2, -3. So this would be -1.5. This would be -2.5. So in this case, you look at -2.5 and -1.5. Well, -2.5 is actually smaller. But if you look to the right side of the number line, 2.5 is bigger than 1.5. So those are things, and especially misconceptions that the students have at first. But when we look at this, and I want to go from greatest to least, well, that would be -1 and 75 hundredths, and then -3 and 25 hundredths from greatest to least. And then -9 and 7 tenths, and then this is just -9. Well, greatest to least would be -9. That is larger than -9 and 7 tenths. And then we think 4/5 and 0. So think 4/5 is just a little bit to the right of 0. So 4/5 is going to be larger than 0. -70 is going to be larger than negative 70 and 4/5, because that's closer to negative 71. Negative 15 and negative 5, well, negative 5 is greater than negative 15. And then 1/2 and negative 2, well, 1/2 is greater than negative 2 because 1/2 is a half unit to the right of 0, and negative 2 is 2 whole units to the left of 0. And then those last three, from greatest to least, we would have negative 99, and then negative 99 and 3/10. So we see we're getting closer to 100, negative 100. But so that's our idea of from our greatest to least and being able to order decimals. Okay, so let's look at percentages. When we're talking about percentages, we're thinking per 100. And so percentages, like I say, are a useful way of expressing values. So if I want to figure out 15% of something, 15% of $250, think about how we would compute that, and think about how if we were, even if we're using the calculator, how we would type that in. Okay, so we've got a specific way we would do that. Well, 15, if we look at the next few here, we've got 15 and 8/10%. Well, if we think about what's that part, and then what's that whole, and then think about how we could use this formula. Well, we know the percent. I'm just going to flip the formula a little bit. We know the percent. I just don't know the part, but I know that it's all out of 100. So you may have been taught, okay, well, it's 15 and 8%. So what would that be? What would that part be if I wanted to change it to a whole number? Well, 15 and 8/10%, we would say needed to be divided by 100. So we would have 15 and 8/10 divided by 100 would give us 158 thousandths. So what we're doing is we're actually, so now if you think about that, we've got our part, and our part divided by to give us our percentage. So I want to change the percent to a decimal, so that would be 158 thousandths. So notice that we're just dividing that number by 100. And then if we did the same for 8 and 4/10%, well, that's 8 and 4/10 divided by 100, because that is our, and since it's per 100, we would say it's 8 and 4/10%. But if I wanted to change that to a decimal, 8 and 4/10% would actually be taking this number and dividing it by 10 twice. So you would get 84 thousandths. And then if you just go the other way, if I want to change it to a percentage, well, I would multiply by 100, which would move the decimal to give me 8 and 4/10%. So 10% as a decimal, that will be 10 hundredths, or 1/10. 5 hundredths would be 5 hundredths. 5% would be 5 hundredths. And then the 1% would be 100th. All right, so let's look at what if we wanted to convert. Let's look at the next one here. If I want to convert 37 5/10% to a decimal. So if I want to find this 37 5/10% of 88, so I know that the percentage is out of 100. And I know, so I could look at a proportion. I don't know how much of 88 is 37 5/10 out of 100. So I could do some cross products. I know we'll get to proportions in just a moment. So if I said, what is the value? What number is, now I would need to change this 37 5/10 to a decimal. And then I could multiply. So when we think about that, we could say, well, what's the part out of the whole? And the part is 31 5/10 out of 100. And so if I change that to a decimal, that's going to be 315 thousandths. But if I want to change that to a percent, I'm going to multiply it by 100. And so that would give me back to 31 5/10%. Okay, so let's look at a context here. During a recent math test, 14 of 25 students received an A or a B. What percent is this? Well, we can certainly take 25 and divide it. How many times will it divide 14? And we can also look at multiples and think, well, 25 is the denominator. What if I multiplied it by 4 divided by 4? Then what that would do is give me 100 as a denominator and 56 as a numerator, which will take me directly to 56%. Now let's look at absolute value and magnitude. So the absolute value of 10 and how it's written. So you'll see these vertical bars around 10. And that just means that we're talking about distance from 0. So what's the absolute value of where we ended? 10? Well, it's 10 units to the right of 0. So what about if we look at the absolute value of negative 10? Well, that's just your distance to the left of 0, and then looking at that distance, negative 10 is from 0, and it's also 10. So notice that they're both positive. So the other absolute value of negative 10 is going to be positive 10. The absolute value of 10 is positive 10. Why is that? And that is because just the distance is positive. That's what we're thinking about when we're working with absolute value. So the absolute value of 10 is 10. And we said the absolute value of, what's another number that has an absolute value of 10? And that would be the absolute value of negative 10. So the absolute value of 3 is 3. Absolute value of negative 3 is 3. So then we can look at evaluating certain expressions. So the absolute value of negative 7 is 7. And then 7 plus 3 would give us 10. We can also look at algebraic equations dealing with absolute value. And so this absolute value of x minus 7 is equal to 12. Well, this just means that we're just going to have two answers that can go in this place. Okay? So your way of solving this is looking at the positive side and solving the equation. And so 19 would work. So think about what's the absolute value of 19? Well, it's 19. 19 take away 7, you get 12. So this one works. But we also want to look at the negative side of this. And so when we add 7, we get negative x is equal to 19, so x is equal to negative 19. So let's substitute that one in here as well. And so what's the absolute value of negative 19? Well, it's 19, and we know that 19 minus 7 is 12. So both of these work, which gives us that we see we have two answers to the absolute value equation. And it would be the same for an inequality as well. So I've got the absolute value of x plus 8 is equal to 23, and negative x plus 8 is equal to 23. So if I subtract 8, I get 8 is equal, or x is equal to 15. And then subtract 8, I get negative x is equal to 15, divide by negative 1, and I have negative 15. So if we check that, the absolute value of 15 is 15. 15 plus 8 is 23. That checks. The absolute value of negative 15 is 15, and 15 plus 8 is 23. So our next item is thinking about order of operations. And it's very, when you think about teaching this one day, it's a very common mistake is to, for students will go out of order because they just want to go left to right and complete this. So think about 6 plus 2 times 7, I said is the answer 56 or 20. Well, think about how you would get that. And if I did 6 plus 2 is 8, 8 times 7, well, that's 56. But if I do the correct order and do 2 times 7 is 14 first, then 6 plus 14 is 20. So the answer is actually 20. The answer is not 56. That would be going out of our order. And so we all kind of grew up with an acronym with what we call PEMDAS. Well, you can also think of it as, you've got parentheses, you've got brackets, you've got grouping symbols, you've got exponents, and then you've got the multiplication and division. I like to write it this way because you're thinking left to right. Everything is left to right when you're looking at your order. And even though adding, if you're looking at PEMDAS going top to bottom, even though adding is above subtracting, it's really, they're just coupled here. So it's whatever comes first as you're scanning it, left to right. So if we look at this example 1, 12 times 4 divided by 6, when I scan it left to right, I see multiplication. So I'm going to do the 12 times 4 first, and that's going to be 48. And now 48 divided by 6, and that would give me 8. Our second example, 9 divided by 3 plus 6 plus 5 in parentheses squared. So I would start with the parentheses. And so I'm just going to rewrite my work. And so that's going to be 11. So I'll have 11 squared. And then I look left to right again. Am I going to do the addition or the squaring part? And I'm going to do the exponent. So that'll be 9 plus 3 plus 121, which is 11 squared. Remember, that's 11 times 11, not 11 times 2. And so now going left to right, I can say 12 plus 121 and get 100. Well, that was division, wasn't it? The whole time that was division, and I put addition. So let me rewrite that. That was 9 divided by 3, 9 divided by 3. And so when I get to this point, left to right. So now I want to look at the division piece. So 9 divided by 3, that'll give me 3, and then add the 121, and I get 124 as an answer. So there you go. That was probably too fine a print for me. I lost it in the translation there. I think I ended up writing addition. So a copy error on my part. But again, looking at it from left to right, that's how you scan it. That's how you go through your order. Other topics with exponents, just evaluating functions. We'll have to deal with exponents in order of operation. We'll look at exponent rules and the properties soon, function notation, composition of functions. So all of those where your exponents are going to be involved and your order of operations will come back into play. This is a fun game. You can, of course, Google it. It's a 4-4s activity where you're asking your students to use only 4-4s and create an answer where the answer equals 0 and the answer equals 1 and the answer equals 2 and 3 and so forth. So, you know, an example of that would be, well, if I used parentheses and I got 8 and 8, in order to get 0, I would need to show subtraction in the middle there to show an answer of 0. Or I could use 4 plus 4 divided by 4 plus 4, and if I use parentheses, that would give me 8 divided by 8, which would give me 1. So there are just lots of ways to for the kids to think about how you can place in your grouping symbols, your add, subtract, multiply, and divide, or even exponents, square roots, factorials. You can certainly Google it. Just do 4-4s activity, and it'll give you some answer keys. It's just a great way for students to be thinking about the order of operations to result in an answer. And then the last part of this video, part 2, is we'll look at properties of real numbers. So think about the commutative property and what that means. And that's where you can switch the numbers around and it doesn't matter. So the 12 plus 53, notice that's going to be the same as if I say 53 plus 12. And so that commutative property does work with addition and it does work with multiplication. 15 times 8 is the same as 8 times 15. Come back to that one. And so this would be, shows that I can turn around the facts and turn around the add-ins and I still get the same answer. With associative property, it's all about your grouping symbols. Well, you really can't add and multiply more than two numbers at a time. So what you do is you start with grouping those two. So when you have 12 plus 15 plus 9 and 12 plus 15 plus 9, if I group these two together, and then if I group these two together, so whether I'm grouping 12 and 15 first, or whether I'm grouping 15 and 9, or even 9 and 12, whatever, I've got to start somewhere. And so notice that 27 plus 9 is 36. Well, this is 12 plus 24, and that's also going to give me 36. So the associative property is just allowing you to group certain numbers to start with, and that does work with multiplication and division. So if I had 3 times 5 times 10, well, if I start with these two and I get 15 times 10, I'm going to get 150. And then if I look at 10 times 5 and I get 50, and 50 times 3, that's also going to give me 150. So I'm going to get the same result. And then I look at the distributive property. And if I have 9 times the product or the difference of 8, 5, that distributed property just means that I'm multiplying 9 times 8 and 9 times 5. So I'm going to see this 9 times 8 minus 9 times 5. And so that would give me 72 minus 45. And so that would be 27 as an answer. Or I could look at it, the distributive property over the course of addition. So that would be 8 times 20 plus 5. If I wanted to break that apart into 2 add-ins, so 8 times 20, so that's 160, plus 8 times 5, which would be 40. So that would give me 200. A common mistake with distributive property is that students forget to multiply it by both terms. Many times they'll just multiply it by the first term. So just remember that property is multiplied by both of those, both of the numbers in the parentheses. So that concludes part 2 of this video series. So we dealt with decimals and we went into percentages, and then we looked at different properties and order of operations.